Thank you, Ken. Good morning, everybody. Again, I am Soliman Khudeira. I am with the Chicago Department of Transportation. I am also adjunct professor with the Illinois Institute of Technology here in Chicago. So my presentation is, I work with the Chicago Department of Transportation, CDOT, so I'll focus on CDOT related work. And the best way to present what we do at CDOT is I'll be presenting to you some selected programs, standing programs that we do every year. And I will cite also actual projects that we are designing or some of them are constructed. And to make it interesting, I included 2 videos at the end, so I hope you will find them interesting. So with that, I will start with this program. Actually, this is the Obama Presidential Center, very interesting. If you are not from Chicago, it's not very far from here. It's under construction. It's about maybe 5-6 miles south of the Loop. But you might ask, well, what does CDOT? T in CDOT is for transportation. This is a private development. What we do at CDOT is do the infrastructure around, the transportation infrastructure around this type of development. So we coordinate closely with any development, and in this case is the Obama Center. So each one of those yellow boxes are buildings, and the one that I just showed you, this one here, is this building. Is a massive, very interesting development in the southeast side of Chicago. What we do at CDOT is improve all the roadways and the bridges around the center. All the roads are shown in black. Those are roadways, existing roadway, mostly existing roadway that will be improved. The roadways that's shown in pink color, those are existing roadway that will be closed. And there are some improvement to underpasses and so on. It's not for orientation. The Obama Center is just very close to the Museum of Science and Industry. So if you are out of town, you could visit the museum and also take a look at this under construction. I'm not sure when it's going to open, but probably in the next 2 years or so. So that's the first type of program, which is coordinating with adjacent private development. And we have other examples, but in the interest of time, I included only the OPC. Another program is this one. I could classify it. This is in the interest of sustainability. This is the current design for our roadways and bridges are very sustainable. And the current design, the hierarchy, it starts with the pedestrian. So the pedestrian, you start with the pedestrian in mind, and then you move to transit. And then the third is, what about bicyclists, accommodations, lanes, and then the auto. But that doesn't mean the auto is neglected. But it is totally different paradigm shift from the way we used to design. I have been a while with CDOT, and I could tell you in the past we have a project or a bridge or a roadway, new road or a rehab, and we start with the auto. It's because it's the most dominant, most prominent user of the facility. So we used to start with the auto, and then when you design the road for vehicles, you're directly or indirectly designed it for transit, because the transit use the same lanes as the vehicles. And then of course you have the sidewalk for pedestrians, and bicycle lane was not in the terminology, but I'm talking 20 years ago or so plus. This type of hierarchy, I would say, adopted by the city around, don't quote me on the years, around 15 plus years ago. So right now when you have a design, you always start from left to right, and you make sure you're designing a facility or a bridge or whatever the transportation facility for all modes of transportation, especially pedestrian, bicyclist. And this is in line of the previous panelists and presenters before me, that you have to do something to help the climate change, to be sustainable, decarbonizations, and so on. And this is an actual example that we already completed, not very far from here. If you would like to visit it, that's Washington Street, maybe only about 5-6 blocks south of here. This is bus rapid transit. In the US, not too many bus rapid transit. I think it started about around 10 years ago. Some cities installed bus BRTs, and this is one of them. This is the first in Chicago. And you can see the modes of transport. You can see that this is fully adopted in this, where you have only 2 lanes for travel for vehicles. Before, the whole road was for vehicles and buses, of course. So how did we do this? We eliminated parking on this lane, gave 2 lanes to vehicles. We created a bus lane, as you can see. We built those very quite elaborate stations or platforms for bus loading and unloading. Then we created a bike lane on the south side of the street. And then by moving the bus loading and loading into the street, right now you have a much wider sidewalk free from people standing and from bus shelter. So this is a direct application of this. So this one is, you could think of it as a complete, as a sustainable design, but the terminology that the city adopted is complete street design, complete for every mode of transport, every user. Another standing program selected. I did not have time to select all of them, but this is the CTA stations, transit stations, an agreement between CTA and CDOT. All the stations, the train station, the transit station, all of the one that's within the central business district is designed and constructed by CDOT, and then turned to CTA for ownership and maintenance. So this is one of them at Damon and Lake. This one is under construction. Oh, again, not very far from here. This is State Street, very interesting street. State Street and Lake Street. So this is a rendering. This project is currently under construction. Another program that I selected, again, in the interest of sustainability, climate change, adaptation. The picture on the top right-hand side is the type of light bulbs that we have been using with the city, which is high-pressure sodium. And then the city has changed, again, around 7-8 years, has started this program to remove all of those high-pressure sodium and change it with LED, light-emitting diode. The benefits are vast. It's LED have much less malfunctioning compared to high-pressure sodium. They consume less electricity. The saving to the city is $10 million per year, which is substantial. But also there is another benefit to the advancement of internet and computer technology. Each one of those lights has an IP address where if the light malfunction, then it alert a monitoring person to dispatch the maintenance agency, maintenance crew to change the pole. While before it was, site investigation, having some notes. Some people here, the city has, I'm sure a lot of you are aware of it, is very effective 311 system. Any citizen, very effective, simple but very effective. If you see anything, if you see a light bulb that needs changing, or if you see a pothole, just call 311. I know the city take it very seriously. It's dispatched, somebody collect it, gives it to every department, and every department act on it. And the reason why I know it's very effective, because my wife uses it heavily. And I tell her, don't overdo it, but she really uses it. Sometimes we are driving and I see some small pothole. It's not really worth 311 phone call, but she still does it. So I think, I know it's effective. The program cost is over $160 million. Bridges, transportation in CDOT, it's roadway and bridges, and I selected just a couple of bridges, not very far from here. If you are out of town, you want to visit it. This is very interesting suspension bridge over, I know I have to watch the time, over Lakeshore Drive It's a suspension bridge with one cable. Normally, suspension bridges have two cables on both sides. This is unique to Chicago, but it's not the first in the world. Just one cable. It's pedestrian, bicyclist to connect the two sides of Lakeshore Drive. This is the other two bridges. This one is on 35th Street, but maybe 3 miles from here, south. And this one is on 41st and 43rd. Very similar concept, but different structural system. Those are true arches. So you look at the concept, it's connecting the neighborhood on the west that's totally separated by like 6 or 7 train tracks and then major Lakeshore Drive. Or how do you make this lake available? They used to be bridges. Before it was connected, but it was very awkward. Wooden bridges and some old, not very safe. Accessibility for ADA is very important, and you can see that the ramps are very accessible with a gentle slope. Then I will move to, in the remaining time, to we in all of our industry, all of your industry, my industry, which is probably very close to the same. You cannot do the same thing over and over. You have to adapt. You have to innovate. And I have seen some in the previous panel, a lot of interesting ideas. So what kind of innovations that implemented or in the way of being implemented at CDOT? And I selected 2, one in design and one in construction. So here is the way we used to prepare all of our industry. If you are engineer or architect or anything, this is how drawing used to be prepared. And we used to, actually this before my time, I never worked on a project where we used this, but the people before us, they did. This is the blueprint. It's blue, it's flooded with blue. Very difficult to annotate, to make comment. Then the industry improved to blue line. The background was white or changed to white, and the lines became blue. Very good. I have done many projects on this one. And then in the past, maybe 10, 12 years, without doing a lot of research on it, the industry, all of us switched to this. I don't know what's the name of this, but I'll call it a PDF. We don't call it black line. We call this blue line. We don't call this black line, but it's PDF files. But it's still very busy. So look at, this is a copy from an actual design, that project we are working on, a bridge. So what do you do when you're looking on the screen on this one? You enlarge it, and it's still very busy, blinding actually. You have no idea what are those lines, and that's a lot of waste in it. Everyone who gets a hold of this drawing, they have to understand what is this line, is this whatever, without going through the detail. So is there better? Yes, there is definitely better. So here is an example from a bridge that actually we are almost completing the design. This is a rendering. So here's what a copy of the picture from the drawing. And you can see, if you're looking at it, if you're a reviewer or in the construction, or if you are a contractor, fabricator, you will start asking, what are those holes? And it will take you minutes, sometimes maybe tens of minutes, just to figure it out. But this is a 2D drawing. What about changing to 3D? And here it is. Look at that. Those holes, 1, 2, 3. Those are conduits going through the beam. And what is this dotted line? This one is, those are stiffener plate on both sides. Another example from this is the same project, that how does this hanger is connected to the arch? Well, here it is, how it's shown on the 2D drawing. So here it is. This is the arch. This is the hanger. Very complicated. You need minutes and hours just to understand it if you are a fabricator or whatever. And here is the 3D drawing. See, it's a little clearer right now. Coloring. Those are all computer software that was used by the consultant. Did a very good job. And then you say, well, is there better than this? Yeah, look at this. You could isolate this, put it on the right, and then even this one doesn't give you the full picture. What kind of plate is this? Is this a square, rectangle, or you could rotate it? And then the picture is very, very clear. So, this plate is this plate, and has this funny looking shape. There is a reason for that. It's not architectural or aesthetics. Is there better than 3D? Yes, there are there are videos that could be prepared for the same bridge. So in the interest of time, I will just advance it, but you get the picture. So I don't know what to call this, maybe 4D or just call it video. Video prepared showing very intricate detail. This, I have to say, is not yet made required deliverable as part of the design drawing. You know, for a project today, what the consulting company delivers to the owner, the client, is plan, specifications, and cost, estimative cost. This one is going to be, I think IDOT already, I work with CDOT, IDOT already ahead of CDOT a little bit in thinking of making this type of computer 3D videos part of the deliverable. You hand it to the contractor, you hand it to the construction team, and look at the clarity. It saves ton of hours just trying to understand how this connected to that, and let me stop it here. How is this, you're asking me to put some conduit here, but what happened? It interferes with this thing, whatever it is. This is the arch. This one shows curve it. It's okay. I already did the design where you can curve it. Those are post-tensioning cables. So without spending, I have to watch my time again. But you see the benefit of that. Answers many, a picture worth 1,000 word, a video worth much more than that. So. And then the last example I want to share with you is related to construction. So this bridge, very large bridge, about 400 feet bridge that we needed to install over this roadway, over this railroad, and you have to keep the rail operational. So there were many challenges. How do you construct this bridge? And this already completed far from here. It's 130th and Torrance. It's about maybe 20, 30 miles. So you don't have to go to that. Go to the close ones I mentioned. So how did we elected to build this bridge? We looked at about 25 options, 25 methods that you could construct this bridge. And one of them is the simplest one, which is just build it the way bridges are always built. You build a temporary support and you start assembling this member with that member, but that would not work here. Would have been really not efficient, not cost effective, not sustainable, dangerous, and so on. So the way we end up selecting the construction method of this bridge is this way. We fortunately we had this land next to the bridge. Here is the bridge where it's going to be. So we negotiated some agreement with the owner of this land. Then the bridge was assembled here on site. This is the blue bridge drawn to scale, and then the bridge was moved on Saturday, moved this way, and then it's placed on its final location. The interesting thing of this method is while you're assembling the bridge, you're also building all those massive support for the bridge. Massive, took months to build those. So you're building this away from traffic, away from the rail. This is major rail by Norfolk Southern, while you're assembling the bridge, and then you move it into place. So that's how it was done. And then this is some end with that, some pictures showing the bridge members assembled very close to the ground. So workers are just standing on the ground and assembling massive part of the structure. Here is the bridge partially completed. Here is the bridge fully completed. And again, it's very close to the ground. And here is the bridge fully painted. You're painting the bridge close to the ground. You don't have to go 30, 40, 50 feet or even more. The top, this one is almost 80 feet above ground. And again, the support structures are, you can see it's already completed, waiting for the bridge to be moved into final location. This is a very quick video showing the bridge being assembled on this piece of land. Very quick video, so you will see the bridge is being assembled close to the ground. And then you will see that it's being painted again. It's completed and then stayed there, lifted up waiting for a closure, because you have to close the road, you have to close the railroad, a lot of coordination. And then the last video I will show is, so okay, before the video, here is the bridge being loaded on those SPMTs. This gentleman is the one who operates, is wired for good reasons, operating all of this massive bridge. This is the support where the bridge will sit, and you can see to scale, this is a human scale that's 6 feet. So those are about 6 feet high. And I will end with that. I'm almost out of time. So this is how the bridge was moved. The bridge is here being loaded. Momentarily you will see it moving. It will be sitting ultimately on this support, and right now it's crossing the rail. And so that's there's time saving, cost saving, schedule, sustainable. By all means, this has been, and it has been used quite with other projects, but this is the first large project that we did with CDOT. That's my presentation. Thank you for listening.